But let's go ahead and just get started with our lesson today. Otherwise, we're going to be here for a while. If I have to take care of that first. All right, so let's get ready for the objective. So solve systems of equations by graphing. Solve systems of equations by using the substitution method. So that's what we're doing today. So what is a system of equations? So a system of equations is two or more linear equations. So you're going to have lines like either slope-intercept form, so that's y equals mx plus b, or you can also have the standard form, the ax plus by equals c, and they are both going to have lines. Okay, they're going to have different slopes sometimes. They're going to have different intercepts, but they are going to have an intersection. So that would be something like right there. So the solution that works for both of them is right where they intersect. Because if I pick that ordered pair right there, it'll make both equations true. And that's what we want. So I could pick areas like on this line and it'll make this one true, but it won't be true for this one. But only this area right here will be true for both of them. But then you also have another option too, and that is there is no solution, right? So you end up with parallel lines. And we've already done a lesson where we had to find out whether lines are parallel, perpendicular, or anything else. So in this case here, there is no solution because parallel lines never intersect. Since they never, cross each other, there's no area where they can both be the same. So in that case, it would be a no solution. And the last type is what we call the infinite solution. And that is because both lines are directly on top of each other. They're overlapping. Or sometimes they call that the same line, which if they were the same line, then why would you, I don't know, it's weird, but yeah, I guess same line does work out. But it's probably better to think of it as two separate lines that are overlapping. And if they are, that means anywhere you pick on the line is the solution for the other one as well. So any ordered pair you pick is going to be equally true if it's on the line because they're all on the line, like all along the way. And don't forget that these lines go on and on forever in both directions. All right, so I've been telling people to get into the habit of making sure your lines go all the way from one side to the other side of your graph and understanding that they go on forever. Now, in this case here, as we solve by graphing, it's going to be even more important to graph really well, all right? So you got to have a straight line also, so you might need something that you can make a straight line with, a ruler, a card, fold a piece of paper, but you want something that you can make a nice straight line with. And it'll make a little bit more sense later. I'm going to turn that off. All right. So let's go ahead and start with this first one. So I have two lines and they are both in slope-intercept form. So y equals mx plus b, y equals mx plus b. That should make it fairly easy to graph this. So I'm going to graph my top line, so -6. That's going to be right here. So that's where the line begins. So yesterday, so I come up with the remember it. I say, yesterday I made excellent breakfast. So begin with breakfast, -6. And if I go down 5 over 3, I'm going to end up off the graph. So instead of down 5 over 3, I'm going to go up 5, back 3. Up 5, back 3. So up 5 and then back 3 would be right about there. And you can see that it's still in line with this point that we don't quite have yet, or it's not really on the graph. And if we try to join it with that point, we might not end up with the line that we need that goes right through the area. Now with these, I'm going to kind of go a few in each direction. So I'm going to go back well, I'm sorry, up 5 and back 3 again. And then back 3. And now I'm going to go ahead and graph this line here. So I'm going to graph my second line that we have in our system. Go up 5, so that's where the line begins, right? B is for begins. And I got to go up 1 over 6, up 1 over 6. And I end up with a line like that. And I'm going to go the other way because seeing this line's going this way, this line's going that way, that probably means that this one's going to go back the other way. So down 1, right? So again, 1/6 is the same as -1 over -6 because a negative and negative will make a positive. So it's the same thing, down 1, back 6, and I end up right there. So that spot is the solution for what I'm looking for. So -6, 4 is the answer. That is the solution set. Now, if I plug, well, let me finish graphing this first really quick. So I'm going to plug in, I'm sorry, not plug, I meant graph. So first thing I'm going to do is graph it. So join these two lines. And now I'm going to go ahead and graph this line here. So do my best to go through them. Now, if I had just graphed these with the lines and the few points I had, you know, it'd be kind of hard to tell that that's where they're going to cross each other right there. So by kind of counting out the slope, I was able to see exactly at what point they crossed each other. So again, -6 and 4, if I were to plug them into this set of equations, it would be true for both of them. So let's go ahead and just go over that really quick. So let's plug in -6, right? So -6 times -5, -6 times -5, so that's 5 times 6 is 30. 30 divided by 3 is 10. 10 minus 6 is 4, and y is 4, so we end up on the top one as 4 equals 4. Okay, 4 equals 4, that's true. Let's go ahead and try this bottom one, -6. So -6 times -1/6, now they are reciprocal, so you could probably already tell what's going to happen with that one. So -6 times 1 is -6. -6 over +6 is -1. -1 plus 5, or 5 minus 1 is 4. And since y is 4, I end up with 4 equals 4, which is also true. Since they're both true, that is the solution for this system of equations. So again, system meaning like there's more than one of them. There you go. Let's go ahead and do this one. I'm going to do the bottom one first, just to, I don't know, get it over with, I guess. It's already in slope-intercept form, which makes it pretty easy for us. So I can mark out the y-intercept, which is 7, or where our line begins, or where we begin to graph it. And this here is a whole number, so if it has a whole number slope, I can turn it into a fraction by putting a 1 under it. So up 2 over 1, but I'm going to quickly run off the graph. So I'm going to go back down the other way. So again, I can go ahead and reverse the slope. So instead of 2 over 1, I get -2, oopsie, over -1. So down 2, oopsie, down 2, back 1, down 2, back 1, down 2, back 1. So I have enough to graph this line, and again, it's best to make it nice and straight, get it all the way across, all right? So please, no little lines like this. There is no such thing as a line that looks like that. And I told you guys when we first started graphing these, make sure you have a line that goes all the way from one side to the other, because I'm gonna go ahead and graph this line now, y equals 5. And remember, if a line is missing one of the letters, like in this case, it's missing x, If it's missing the x, that means it does not touch the x-axis. So we have a line that runs parallel. Now, believe it or not, I do get students who will try to graph something like this and be like, oh, there's no solution because they don't cross each other. Well, that's why I keep telling you, make sure whenever you graph something on a line, on a graph, you make sure the graph goes all the way across. Because now that the graph is all the way across, I can easily see my solution is at -1. So let's see, -1 up 5 is the point that they intersect, which means that is the area that makes them both true. Okay, so we're done with those two. Let's go ahead and move on to the next set. Now, the other ones were a little bit easy because they were already in slope-intercept form. And in my opinion, slope-intercept form is probably the easiest one to graph. And it also has the added benefit of being able to tell at a glance, will these lines be parallel? Because if you can see the slope, then you can see that the lines are easily parallel. Now, we don't oftentimes use standard form, like these ones. These are standard form, ax plus by equals c. But sometimes, like in this case, they're already in standard form. So it helps to remember standard form graphing. Because not everything's going to be in y equals mx plus b. So to graph these, I am going to go ahead and I'm going to do the thing where each variable, x and y, take turns being 0. And again, that's kind of like taking somebody else's picture or another family's picture so they can have all their family members in the picture. And then they do the same for your family. All right, so both people win in that case. So again, you got to have them each take turns. So one person has to sit out here, and I'm going to go ahead and make it the y. So y is equal to 0. Now, now if y is equal to 0, -5 times 0 is 0. -5 times 0 is 0, so 6x minus 0 is just 6x. So I don't need it. I'm just going to ignore it. And I get 6x equals -45. And it looks like I'm going to have to divide both sides by 6 to get that by itself. And x equals, let's see, 6 times 6 is 36. And add another 6, that's 42. And I think that would be 7.5. So there we go. I know on the x-axis, oh, almost forgot the negative. Now, you got to be careful with these. They're not any tougher than regular equations, but you have to follow the steps very closely. If you do anything, a small mistake, everything after that is not going to work. So you got to pay extra attention to things like your negatives and your calculation, because again, if any small mistake is going to kind of ruin the whole thing. So x equals -7.5, which is about right there. And now I need to do the same with the x. So x will now be equal to 0. I'm gonna kind of erase it and move it over here. So x is equal to 0. So 6 times 0 is 0, so that zeroes out. And that leaves me with only -5y equals -45. So y equals 45 divided by 5 is 9. Now they're both negative, so if I divide by a negative, that means that the negatives are going to cancel out, so I don't have to worry about that anymore, the negative. And that means it's going to cross up here. And let me go ahead and do my best to connect these lines. And there we go. And again, they have to be pretty straight and pretty precise. And one reason, again, I don't like standard form graphing is because in this case, it's kind of hard to count out the slope and the intercept. But let's see if we can graph this second line good enough that we can easily put it in here and find out where it's going to cross. So I'm going to do the same thing, 2 times 0 plus 2y equals -4, and then 2x plus 2 times 0 equals -4. So again, I'm going to make each of them take turns being 0. And this cancels out here, and this cancels out here. 2y equals -4, and 2x equals -4. Now this kind of makes it a little bit easy because both of them are 2. The coefficient on both of them is 2, 2y, 2x. So if I solve one, I basically solve both of them. So in this case here, x equals -2 and y equals -2. All right, so x is -2 and y is -2, so that'd be down here. I almost put it up here. Again, be careful with that. You don't want to mix up your axes. You don't want to mix up your numbers. And let's see, that's going to be over 2 like that. And that means no solution, right? No. Again, please don't fall into that habit of making your lines really short and not able to connect with each other. All right, now we need the actual answer, the actual solution that we're looking for. All this is not really the solution, it's just there to help us to graph it. So if I look here, it looks like we're going to go back 3 and then up 5. So where can I put this? Back 5, up 3, and put them into a parenthesis because it's an ordered pair. And there we go. So answer to that one is -5, 3. And if I plug them into these numbers here, I should be able to get both of them to come out to be true, which that's how you would check it algebraically. All right, number 4 now. Ooh, this one looks like a bit of a tricky one because one is in standard form and the other is in slope-intercept form. I'm going to go ahead and graph the slope-intercept form first. So just because it looks like it's easier to graph. So -5 and then down 1 over 2, down 1 over 2, down 1 over 2. Now I can also go back this way just to make sure, you know, my line might go this way. I'll go maybe 1 or 2. But anyway, there we go. And now I'm going to graph the top one. Now I could use standard form graphing where I make them take turns being 0. But something's kind of weird about this one. What's weird about it is that 3, 6, and 12 all have a factor that they can all be factored by. In other words, I can divide all 3 of them by one number. And that's a little bit suspicious. Now you could still graph it the way I did before, where I make them turn into 0 for x and y. But I'm going to do something a little bit different with this one here. I am going to turn it into slope-intercept form. So the first thing I'm going to do is I'm going to minus 3x from both sides. So if I minus 3x, it goes away on this side. So minus 3x equals 12. Now the reason why sometimes it's a good idea to put them into slope-intercept form is, again, slope-intercept form is useful because you can see some of the numbers that your slope is made of. So in this case, I have 3 over 6, which I can reduce that to 1/2. And I have here 12 divided by 6, or actually -12 divided by 6, which would be -2. Now you notice that there is something weird. And again, I did tell you that all three of these numbers can be divided by the same number. So when that happens, it means it's not in simplest form, which sometimes it means they're trying to trick you. So if I graph it, -2, and then down 2 over 1, down 2 over 1, down 2 over 1. And I could keep going with that, but in this case, I don't think it's really going to help all that much. Do my best to connect the lines. And we end up with parallel lines. And we know they're parallel because they have the same slope. They're both -1/2. So they're both down 2 over 1, down 2 over 1, down 2 over 1. So that they are not going to intersect. And that is one of our special cases that we had before. Oops, caps lock is backwards. There we go. All right, so that means in this case, there is no solution. All right, since they never intersect, there is never a place where they are both going to be the same, and there is no point that is going to make both of them true, so no solution. All right, so I guess we're done with this one. Let's go on to the next set. Now with these, I kind of feel the same thing on these as well. So on number 5, this one is almost in y equals mx plus b form. I just need to divide everything by 2. So that's what I'm going to do, divide everything by 2. So 2 divided by 2 is 1. 1y is just y. 8 divided by 2 is 4. 18 divided by 2 is 9. So now I have my first line. And I'm going to graph this. I guess I'll just graph it now. Now again, I run into that same problem. If I go up 4 over 1, I go off the graph. So I'm going to have to go back 1, down 4, right? Go the exact opposite direction. Now, when I do that, sometimes people just make it negative on one side and they make the line go down. So remember, it's only going to go down if the slope is negative. And again, it always goes from left to right. You look at these graphs from left to right. The direction that you read, or most video games that have side-scrolling action, usually go from left to right. So you always got to go that way. So down 4 over 1, down 4 over 1. Wait, no, I think I made a mistake. 1, 2, 3, 4. All right, that about there. And then down over 1. And down over 1. Okay, now let's go ahead and get this second one graphed. And this one's a bit of a tricky one because it's not in slope-intercept form and it's not in standard form. So I have a choice, and I think I'm going to go with slope-intercept form. And like I said, I think slope-intercept form is a little bit better because you can easily tell if something weird is going on because the slope is going to be a little bit different. The slope will tell you a lot about what's going to happen. All right, so minus 24 from both sides. So 24 goes away from this side, and I minus it here, so it becomes x minus 24. So that's all I did was minus 24 on both sides. Oh, sorry about that. I wish there was something I could do about that. Unfortunately, the internet is what it is, especially in this town. You know, I mean, anybody who's does a lot of stuff online, it's really frustrating when it keeps going out. But don't worry, I'll have this video posted soon for this lesson. It's the best I can do. Anyway, let's go ahead and continue. So I have 1 in front of the x. So that's going to become 1/4 x minus, and I think that would be 6. Okay, so let's go ahead and mark out 6 and then go up 1 over 4. Yeah, up 1 over 4. And then it looks like the line's going this way, so I'm going to try to make them connect over here. Down 1, back 4. And that looks like if I go back on the green line here, down 4, back 1, it looks like they're going to meet right there. So this is the solution point. So my solution point is -4, -7. So that's the solution point for that one. Now let's go ahead and draw our lines, because it does say in the directions it says to graph it. So we got to graph it. And we identified the solution already, so that takes care of that. Right, there we go. Whew. We did our best to connect those dots, and it worked out pretty well. All right, last one for this one here. That top equation looks like it might already be in slope-intercept form, but it's not, because it's not entirely solved. It is negative. So that means I got to get rid of this negative also. But luckily, that's pretty easy to do. For this one, I am just going to, well, I can divide everything by a negative, or I can times everything by a -1. Whatever you do, multiply or divide by -1. It's going to switch the sign, but none of the numbers. And let's go ahead and take care of this one. Now, again, this one is not in standard form, which if it was in standard form, I could easily just graph it and see what comes out. But it's, well, it might be easier to put it into slope-intercept form, because if you look at it, y is kind of already by itself as long as I get rid of that 3. So here's what I'm going to do. I'm going to use reflexive property. Now, I've been using reflexive property with almost every lesson I've done so far. All that happens is I switch the side. So 3x plus 18 over here is now on the other side, and 3y is now on this side. So they just switch like that. So they switch places. Now I'm going to divide everything by 3. And again, some things tells me it's going to be a bit weird, because all of these numbers can be divided by 3. So 3 divided by 3 is going to be y, and 3 divided by 3 is going to be x, and 18 divided by 3 is going to be 6. Now, if we look at it, that's a bit of a weird thing. We have both equations come out to be the exact same thing. Now, since they're not likely going to cross, I'm just going to go ahead and graph it like this, and I'm going to have a second line. Oops. I'm going to have a second line going this way as well. So we end up with something like that. And when this happens, we got infinite solutions. So both lines are overlapping, or sometimes again we call it the same line, which means that they are going to be true anywhere along the line. Any number we pick, it's going to be the exact same thing for both of them. So there you go, there's one case. Now, that's how you do graphing. Let's move into the next thing, which is solving by substitution. So to solve by substitution, you're going to follow these steps, and it's going to sound confusing, but it's honestly not that bad. I think once you see a couple of them, it's not so bad. So the first thing you got to do is solve one of the equations for x or y. In other words, you got to isolate one of the variables. Once you have a variable that is isolated, you take whatever's on the other side and plug it into the other equation. And essentially that's going to do is it's going to get rid of one of your variables, either x or y. Now, you cannot solve an equation if you have two variables, if you have two different things. You have to make it so there is only one. So that's why you're substituting it in there, because you're getting rid of one of the variables. And then you solve it for that variable, but you're not done yet. Even though you get one of them solved, you got to substitute it into the other. So put the answer you got and plug it into the other equation. And like I said, it sounds confusing, which it kind of is, but I think it'll make more sense once you see it. Now with this one here, this first one is kind of a bit of a tricky one because they're both solved for y. And when I do this, I feel like sometimes students don't really see what's going on. But here's what's going to happen. So I have 7x minus 1 equals y. Now, by law of the equals, right? The equal sign means that they are the same thing on both sides. So y and negative 7x minus 1 are the exact same thing. And remember, these are systems of equations, meaning there's two of them, and that means they are together. They are on the same graph. So if that's the case, I'm going to take this and I'm going to plug it in where this one is. So I end up with negative 7x minus 1 equals, the equal sign is the same, and this here is x minus 9. So again, I grabbed the 7x minus 1 and I plugged it in where the other y was. Now, when I do this, sometimes students will say, well, you just set them equal to each other. And that's kind of true, but it's not the whole story. And this is not a very good example to have as the first one, just in my opinion. But anyway, let's continue doing this. I want to keep my 7x positive, so I'm going to add 7x to both sides. And while I'm at it, I am also going to, since this canceled, I'm going to cancel this 9. So I'm going to add 9 to both sides. So again, they do the little trade where they each have what the other one has. And let me go ahead and combine these. 9 minus 1 is 8. And 7x and x will be 8x. And now I can ask myself, okay, well, what number times 8 can give me 8? Well, 8 times 1 is an easy, it's easy to figure that out. I don't really need to divide both sides by 8, which I guess you can if you want. Anyway, let's go ahead and find the other one. So we're not done yet. We have one of the solutions, but we need both of the solutions. Now what I'm going to do is I'm going to take one of these and I'm going to plug it into the other. So y equals 1 minus 9, because now I took 1 and I plugged it in for x, because now we know that x is equal to 1, and that should give us our y value. Y equals 1 minus 9, which is 8. We have both of them now. They're both there. So 1 and 8. Make sure when you put them into an ordered pair, you make sure the x goes first and the y is the second one. Now it's really easy to mix them up sometimes. But in this case, that's our answer is 1 and, oh, should be negative 8. Because in this case here, I'm minusing that one. Now, if something like that happens, you can also check on Desmos. I think there is one of these that we might try on Desmos, just to try it out, if we have time. Okay, so there we go. So let's go ahead and do this next one here. So I have my top equation, is already solved for y. Y is already by itself. So what I need to do is I need to take all this and drop it in right there. Because again, this y and that y are the same thing. So if it's solved for y, take all of that stuff, the negative 5x plus 30, and put it into the other one, into the 3y, take that y out, and we're gonna have to put in that stuff. So 7x plus 3y, but instead of y, I'm gonna go ahead and leave me some space here. 3y equals 42. I said 42. 42. There we go. 7x plus 3y equals 42, and I'm going to drop this in where the y used to be. Now from here, I'm going to have to use my my regular skills of algebra. Negative 15 plus, and let's see, that'd be 15x plus 90 equals 42. Okay. Now let's see, combine these two things. 7 minus 15, so that'd be negative 8x and minus 90, so minus 90 here, minus 90 there. And let's see, 42 minus 90, that'd be 48. No, wait, yeah. No, wait, yeah. For 40 plus 40 is 82 plus 8. Yeah, okay, yeah, it is 48. Negative 48. And since both sides are negative, I'm going to have to divide by negative. So x equals 6. Now again, that's only the first part. I get students all the time that get here and then they're like, oh good, I know x is equal to 6 and I'm only looking for x, right? No, you're looking for both of them because you need to know where the x and the y are, where the lines cross each other, where they are both true. So I'm going to go ahead and erase this so it'll be easier for me to plug it into either one of these. Now, when you get to the here, you can plug it into your top one or your bottom one, but you can save yourself a little bit of work by picking one that might be easier to work with. Now, I'm going to pick the top one, not because it has smaller numbers, but because the y is already by itself. So you see when I start plugging things in, now that I know x is equal to 6, I'm going to plug it in for x. Now, I only have to work on this side. I don't have to work on this side. I don't have to do the add or subtract both sides or multiply and divide both sides. I can keep everything the same. And in this case, negative 5 plus times 6 is 30. Sorry, negative 30. So that means y equals 0. So 6 and 0 together, like that. Now, we are done with that one. Let's go ahead and box that up and move on to the next one. I don't think either of these are really that tricky, but I know on some of these, it's going to get a lot trickier. Okay. Now, with number 9, there's a bit of a problem, and that is we don't have any of the variables solved. So x or y, neither of them are by themselves, which means that we are going to have to solve one of them. And if we look at the top equation, I have two options. I can either divide both sides by 6, so that way the x would be by itself, but then I'd have 5 over 6 and 28 over 6 as fractions. That doesn't work out. I could also divide the top one, divide everything by 5 or negative 5. But again, we would end up with fractions, 6 over 5 and 28 over 5. So on the top, we don't have any options. bottom one, we only have one option, and that is to solve for y. Now, the reason why we're going to have to go with this one is because y is already by itself, and I can't divide everything by 7, and since it's already by itself, all I have to do is minus 7x on both sides. So minus 7x. So when I minus 7x, it's going to cancel on this side, but it's going to appear on that side. There we go. Now I have y solved. So I'm going to take this y and I'm going to plug it in to this one. 6x minus 5y. And again, I'm going to have to leave some space in here, negative 28. So negative 7x plus 22. Now oopsie. Now I'm going to have to use my distributive property, 6x plus 35x. And negative 5 times 22 is negative 110, because 5 times 2 is 10, and 5 times 20 is 100. So put them together, 110 is 110. Okay, now let's go ahead and put these together, 6x and 35. So 6x and 35 is going to be 41x equals. And with all of these, I think there are not going to be any of them that are fractions or decimals. So if you get a fraction or a decimal, you might have made a mistake, although we're not, cannot be 100% sure. So I'm going to have to add 10 to both sides. So it's going to be 82. So add 110 to both sides, that's going to be 82. And 41x equals 82. That means x is going to be equal to 2. Whew, okay. Now again, I have a choice. I can either plug it into the top one or into the bottom one, either one of these. Now for this one, I think I'm going to plug it into this one here. So let's try that. So 7 times 2, I'm kind of out of space, so I'm gonna put 7 times 2 because x is 2. 7 times 2 is 14 plus y equals 22. So what number can I add to 14 to get 22? And in this case, I would get 8. Just minus 42 on both sides. And that would be 8. But now I have both things of my solution. I have both points, the x and the y coordinate for this one point. So over 2 up 8. Now just to, I'm going to go ahead and plug this into my, into the Desmos. And I know I picked one of these already, but I think we can. I don't think you can see my screen. Maybe you can, maybe you can't. But all I'm doing right now is I'm at Desmos right now. I'm plugging in 7x plus y equals 22, and it says the answer, the solution is 2, 8. So let's go ahead and I'm going to go over to Desmos, and I should get 2, 8. So over 2 up 8, which is true. And again, you can check your answers with Desmos by doing this. Now you still have to graph it. You are still going to have to graph it, so you can't just use Desmos to get your solution right off the bat. But these are lines, they are able to be graphed, and you can check them on the graph, which we just did. And this one worked out. It did come out to 2, 8. And now we kind of run into that same problem with number 10, where it looks like we only have one number we can solve for, one variable, and that is x. So I'm going to have to change this top equation, and we're going to have to solve it for x. So let's go ahead and I'm going to add 7y to both sides. So 7y equals, not equals, I'm looking at this thing here. That would be plus 53. Double check it, make sure I didn't put anything in the wrong place or switch any signs. But there we go, we have that. So since we have x solved, let's go ahead and plug it into here. So -4, and instead of x, again, I'm going to plug in all this stuff that x is equal to. So x is the same thing as 7y plus 53. So there's -4x minus 5y equals 19. So that's going to be -28y plus, and let's see, -4 times 53. It's going to be a negative because I'm multiplying it by a negative. So 4 times 53. So 4 times 3 is 12. And 4 times 50 is 200, so 212. Minus 5y equals 19. And let's go ahead and put some of these things together. So here I have -28 and -5 would be -33y. And I'm going to have to add 212 to both sides, so plus 212. And I'm going to use my calculator here, 19 plus 212. And I get 231. 231. And I'm going to divide that by 33, which gives me 7. So y equals -7, because we'd have to divide both sides by -33, not just positive 33, because then the negative would still be there. But my calculator that comes with the computer cannot do negatives. I cannot do negative numbers with it. Since I can't do negative numbers, I just have to keep those negative numbers in my mind. Now this one also has something different in that we have a y value as our first answer. So when you're putting it into an ordered pair, just keep in mind that the y value is the second one. My thinking is that some students will kind of make the assumption of, I found it first, so I'm going to put it into the ordered pair first. But no, x and y, they got to go in the right place. So make sure you put that x and y in the right place. So let's go ahead and pick one of these and put them in there. Now, since I'm looking for x, this is something else that you should be careful of doing, but you can do it if you're pretty good at your algebra skills. I would recommend you go back and plug it into one of the originals. But in this case, I honestly didn't change a whole lot. There's not anything that's a big change. So the chances of me messing up something is really low in that whole thing. So I'm going to plug it into here. So x equals 7y, but I know that 7 is -7. So 7y plus 53, 7y plus 53, but y is -7. And this becomes 7 times 7, which is -49, because one of them is negative. 53 minus 49, x equals 4. So that means my first value is 4. And again, be careful, because a lot of people tend to put the first thing they find into the x slot, but no. You got to put them in the right place. There is an x and a y. All right. Last one. Okay. Now let's go ahead and, well, that top one looks like it's already in slope-intercept form. So let's see if we can put it into slope-intercept form. Now what I need to do is I need to divide everything by 2. And I can't do that, otherwise it would look really messy. So I'm going to divide everything by 2. So I'm going to just put divide by 2 like this. Y equals 3x plus 5. Now this is getting me suspicious, because if I look at it, 5 here, 3x here, and y. This means that they could be the same line. So instead of trying to graph it, what I'm going to do instead is I am going to put them both into slope-intercept form. So again, I'm going to forget about solving it by substitution, because in this case, I'm suspicious to think that they will both be the same line. So again, I think in this case, it'd be best to put them into, both of them into slope-intercept form. So what I'm going to do is I'm going to take 3x and minus 5 and add y. And let's see, 3x minus 5. So again, I just minus 5, so that's why I got minus 5 here, and I minus, well, actually I added y, so that's why y is over here now. And y equals 3x minus 5 and 3x plus 5. Now this means they are not exactly the same line, because one crosses at positive 5 and the other crosses at negative 5. So again, that means they are likely not the same line. But what else does that mean? Well, if I try to plug it in, if I try to substitute it, let's go ahead and I'm going to take this one here and I'm going to plug it into this one. So 3x minus 3x plus 5 equals 5. So there, that's my equation, but I'm taking 3x plus 5 and I dropped it in there for y because I solved it. Now, let's say you didn't see it right away. Okay, you weren't me and you weren't looking at this and saying, wait a minute, that's a little bit suspicious. Well, okay, you can do that and just plug it in. Now, if you know what's going on here, you probably would know enough, but that's why I'm doing it right there. So that way you can see, you know, what you would do next. So let's go ahead and distribute that negative. All right, no, that'd be just negative 5, not 15. I almost thought that 3 was part of the distributive, but it would just be 5. Now 3x minus 3x, that would be 0. They canceled each other out. Now, luckily for us, if you remember solving equations for special cases, it's the same rules. If you are trying to solve it as an equation and you lose one of the variables falls out, which in this case, x zeroed out. 3 minus 3 is 0, so 0x is just no x. But you got to check it. If it is a true statement, then it is all real numbers or infinite solutions. However, this is a false statement. Negative 5 equals 5. They are not the same thing. 5 and negative 5 are not the same thing. So in this case here, there is no solution. And if I graphed it, you would see that they both have the same slope. So they would, if they have the same slope, that would mean that they are parallel. So we found 2 different ways to prove that this is a no solution. One, the slopes match without the y-intercepts matching. And if we try it algebraically, we get a false statement. Now this next one here was just a big old headache for me. I got frustrated with this one in most of my classes. I would like to just graph this one. But I guess I shouldn't try to avoid the difficult ones. So I'm going to just go ahead and do what I've been doing most of the morning. if I look at my top one, I can't divide everything by 5 because then I get fractions. If I divide everything by 7 on the top one, I still end up with fractions. So I can't really divide everything on my top. So let's try the bottom one. If I divide everything by 4, I get fractions. If I divide everything by 3, I still get fractions. So this means it's unavoidable. I can't avoid it. Now, I tried both ways with my different classes. This morning, I switched between the two. So you guys are lucky because you guys get to see the method that works best. So I want numbers that can be turned into decimals. If I have everything divided by 3, this becomes 4 over 3, which is 1.33333 repeat. We don't want repeating numbers because you can't work with repeating numbers. You cannot add, subtract, multiply, or divide repeating numbers. So I'm going to have to divide everything by 4. Now that means x is going to be by itself. Now I'm also going to have to add 3y to both sides. I'm sorry, 3/4 y to both sides. And that's going to move it over here. So my new equation is going to be x equals, now x is by itself, which is what I wanted. Now the y is going to still be there. I didn't put the y on that one. I almost missed that. Now I'm going to put the y first, just because that's habit of I guess, my habit. But 3/4, I can turn that into a decimal. Unlike all the other ones, 5/7 or 7/5 will not be a decimal number. You're going to get some repeating number, which again, you can't really work with those. And like I said, I've already tried it different ways, and this is probably the best way, is to just turn it into a decimal. I know I say not to do it sometimes, and sometimes you just got to learn how to work with a fraction, because sometimes you just won't have a choice to use a fraction or not. But in this case here, again, I've tried it already. It's not going to work as well if you leave it as a fraction. But now I have -5/4. So that's going to be minus 1.25. And if you're not sure how to do this, just grab a calculator and type in 5 divided by 4. And you'll immediately get your decimal number. Now again, you can do this with fractions, but it's going to be I'm not even going to bother with it, because you're going to end up having to like add a mixed number to a fraction, and then turn an improper fraction into a fraction, get common denominators, which is bottom numbers that match, and then add those, and then divide both sides with a fraction, which again, that is pretty tough. So that's why I'm saying let's just go with decimal. All right, so now I have x. Since my bottom equation is the one that I used to get this, I'm going to use my top one now. So that's going to be 5, and what should be x will go there. 5x plus 7y equals -17. And I'm going to grab this here and put it in here. So 0.75 y minus 1.25. Now I'm going to also use my calculator for this one here. So make sure I don't make any mistakes on this. So come on, 5 times 0.75, and I get 3.75y plus, and now I get 1.25 times 5, and I'm going to get 6.25. 6.25 plus 7y equals -17. All right, make sure all that stays the same. Now, since I have 3.75 and 7, so it's going to be 10.75 y. I'm also going to have to minus 6.25 from both sides. Minus 6.25. So it looks like I'm going to have to add the values of 17 plus 6.25. Hold on a minute. Oh, no. That doesn't look right. I almost missed this part here. And like I said, sometimes it does get a bit hectic because you have so much things to to watch out for. So it's really easy to mess things up. All right, so in this case here, that's going to be pretty easy. Oh, shoot, I almost forgot the negative on there too, because this is negative 17, so that's going to make the result in the next step negative. So it's going to be negative 10.75. Woo, okay, like I said, this one's going to be a doozy of a problem. All right, so y equals -1. Y equals -1, and now I'm going to plug it into one of these original equations to see if I can get it to be a little bit, find out what the x is. Or maybe I could plug it into this one here. I think it might be easier to plug it into this one. And now again, that's a risky move because I'd have to do a lot more work to get this one here, but yeah, I'm going to try this. I didn't try this before. So if I times it by -1, that's going to make this negative 0.75y minus 1.25. And there's going to be no y because I just multiplied it by -1. And that's going to be x equals -2 because 75 cents plus $1.25 is going to be $2. So it'd be 2.0, but I don't need to put the 0.0 on there. That's not really useful. So there we go. I have my answer here. So -2, -1 ordered pair. And that's it for today. That's it for the lesson. So, could have sworn there were more people here, but oh well, it is what it is, I guess. Anyway, as always, I'll be around to answer any questions if you want to. If not, I guess that's it for today. Bye-bye now.